Okay, in the summer video, I'm going to talk about the normal distribution and namely the empirical rule. So the first thing you should know about the normal distribution is that it is expressed as a quantitative variable. So quantitative means, for example, SAT scores are numbers, so they have a rank. In other words, 700 is less than 1500. So this is a histogram to where frequency is on the y-axis. So it tells you the frequency or how often these scores take place. So SAT scores are normally distributed, or at least approximately normally distributed, because most people score in the middle. Okay, so and then the frequencies get less as you get further away from the mean. 1500. This is the old scoring for all three sections: math, verbal, and critical reading, or I think that's what it was. The average was 1500. Okay, so this is what we're looking at. But just the first thing to know is that it is simply a histogram for quantitative variance. So you could not have a normal distribution for color, okay, because there would be no rank down here for yellow being to the left of red. You could have a bar graph, and you might have higher frequencies in the middle, but that's not normally distributed. Okay, so that's the first thing to figure out. So the second thing is the main thing we want to focus on is the empirical rule. So the empirical rule says that if a variable is normally distributed, then 68% of the data will lie within one standard deviation on each side of the mean. So, and then 95% will lie within two standard deviations on each side of the mean. And almost all, 99.7% of the values lie within three standard deviations of the mean. So that is the empirical rule. It's important to know those numbers. It's not 97% for three standard deviations. It's 68, 95, and 99.7. So what we're going to do is apply it. So not just memorizing the numbers, but being able to apply it is important. So that's what we're going to do. So I have a problem. The problem says IQ scores. So I'm actually going to run through 6 different examples with the same problem. So it's about IQ scores. IQ scores are normally distributed. The mean is 100 and standard deviation is 15. So you may not understand what a standard deviation is right now, but just to understand it's a typical difference from the mean. So if somebody makes an 85 on an IQ score, that's a typical difference away from 100. That would just be one standard deviation below the mean. All right, so to answer these questions, we have what percentage of adults have an IQ between 70 and 130? So to answer this, I'm going to draw a curve. And I suggest you draw a curve on all these problems. Okay, so draw a normal curve. It doesn't matter what it looks like. And in the middle of this curve will be the mean. So the average IQ score, the mean IQ score is 100. And I write my standard deviation of 15 right there. So my standard deviation is 15. So what the empirical rule says is that if I go one standard deviation above and one standard deviation below, which would be 115 and it would be 85, that represents 68% of adults. So 68% of adults have an IQ score between 85 and 115. So this question asks us about 70 and 130. So this one happens to be one more standard deviation above and one standard deviation below. So 130 is exactly 2 standard deviations above. 70 is exactly 2 standard deviations below. So to answer part A, it would be 95%. And go back to the empirical rule. The empirical rule says 68% will lie within one standard deviation on each side, and 95% will lie within 2 standard deviations on each side. Okay, and then remember 99.7% will lie within 3 standard deviations. So that's A. Part B says what percentage of adults have an IQ less than 85? So again, I'm going to draw this curve. This one a little less straightforward, but we can use the empirical rule. So I have 100. I have standard deviation is 15. And I'm trying to find the percentage of adults that have an IQ less than 85. So 85 is 1 standard deviation below the mean. Exactly 1 standard deviation below the mean. And I'm trying to find the percentage that have less than that. This percentage right here. I'll go ahead and shade it in. Okay. So the way we have to do this, I'm going to use this with the empirical rule. We'll actually learn another way to do problems like this. But 115. If I have this value of 115, I know that 68% lies within 1 standard deviation on each side of the mean. So how does that help me? One very important thing about the normal distribution is that it's perfectly symmetric. That means a couple of things. It means the mean is equal to the median. That's one thing. So in other words, the mean is 100. Also, the median, which would be the 50th percentile, is also 100. So the mean is 100, but that also means that half of people have an IQ less than 100, and half the people have an IQ of greater than 100, or greater than or equal to 100. They're both less than or equal to, or greater than or equal to. That's the median. That's the first thing. The second thing means that if this percentage right here is the same percentage as this, it's perfectly symmetric. So if this is 1 standard deviation below the mean, this is 1 standard deviation above the mean, this percentage is just the same as that percentage, the other one shaded. That's important, okay? So now I know that 100% should lie under the curve. Everybody has an IQ score. So even if it's way out here, another thing to remember, 3 is not the maximum standard deviation, very close, but there's people that have IQ scores that are above 3 standard deviations more than the mean, okay? So, but we have 100% is going to lie under the curve. We already have 68% in between 85 and 115. That will leave 32% that lie either here or here. And we just learned that it's exactly equal. So you can cut 32% in half and get 16%. Okay, so 16% here, 16% there. You can rewind the video if that needs some help there, but 100% under the curve, 68's in the middle. That leaves you 32% in the tails, and 16% in each. Okay, moving on to the next one. What percentage of adults have an IQ greater than 145? So now all the questions that I ask you right now have to be exactly on 1, 2, or 3 standard deviations above the mean, because that's all we're learning right now is the empirical rule. So 145 is 1, 2, 3, 115, 130, 145. Okay, and what we know about the empirical rule, and I really don't need to figure out what these are, but if you did want to, that's 85, 70, and 55. So we know that, and I'll write it as a decimal this time, 0.997, 99.7%, because you got to be able to use those interchangeably, a percentage and a decimal, lies within 3 standard deviations. So again, the idea that the whole curve is 1, or 100%, means that, and I know this thing is perfectly symmetric, so this little area right here is equal to this little area right here. So if I subtract 1 from 0.997, I get 0.003, and that is the area combined in these two tails. So I would need to divide that by 2 to get the area in each one. So that is 0.0015, which is the proportion of adults who score above 145, which in some cases considered to be a genius. So that would be 0.15%. Okay, or you could just leave it as that. Again, I'll use them interchangeably. So that's the proportion, that's the percentage of people who score above 145. Okay, 3 more. Dylan, still with the empirical rule, and that's going to be it. So still with the same example, what percentage of adults have IQs between 100 and 130? So again, I'll draw this curve. I have 100. 100's in the middle. We know that. 115, 130 is 2 standard deviations above the mean. So if you want to pause the video, see if you think you can come up with it. I just want this area between 100 and 130. So the way that you would do it is realize that 130 is 2 standard deviations above the mean. And if I came and found this point right here, which is 70, but you don't necessarily have to know that, that is 95%. The empirical rule says that 95% will lie within 2 standard deviations. Okay, and then perfectly symmetric, even though my graph doesn't look